Okay. Thank you very much for joining us today. This is App Builder Live. It is Thursday morning here, anyways, in California, 9 o'clock. So hopefully you are having a fantastic day. And we have a really excellent session for you today. It's going to be, we kind of broke it up into a couple of sections. Kelvin's going to be here to talk about deployment strategies for about first 15 minutes, and then we're going to jump into um, the scaling, how to scale app builder applications. Super critical information for any app builder developer. But before we get that started, I did want to remind folks that we have we have Adobe Developers Live that is coming up on Tuesday. So please, if you haven't registered already, join us at developerevents.adobe.com. And yeah, so we will be kicking off. I'll be hosting the keynote and I guess the beginning and the close. And there's a bunch of great sessions about composable experiences in AEM. So if you're an AEM developer, it's a fantastic way to get to see what we're cooking up here at Adobe. Okay, now without further ado, let me bring in Kelvin. How are you doing, man?
Good, good. Hey, Ron, good to see you. Thanks for having me.
It's good to see you too. And then I'm going to bring in Jesse as well. So
Hello.
thank you for joining us, Jesse.
Thank you.
So Kelvin, just give us a quick, what do you do at Adobe? I can't remember.
Sure. I'm a AEM principal architect of Adobe Consulting Service, of course, in the AEM practice. I have about like 18 years of experience in AEM technology and web content management, digital asset management industries. So I'm also a focus lead of App Builder, especially by leveraging App Builder to do AEM integrations. So this is why I
Right.
come to this board to share some knowledges and
That is
learnings.
great. Yeah, and I can't believe we haven't had you on this show before because you're the perfect person to come in and tell folks how to use App Builder, especially with AEM. And then Jesse?
Yeah, I'm more behind the scenes. I'm doing a lot of the tooling and enabling app builder apps to exist. So a lot of the plumbing, a lot of the lower level work. So all the CLI my team works on. Yeah, and then everything managing deployments to seeing your app live.
Right on.
We're making it all happen.
Excellent. Thank you very much, Jesse. So as I mentioned, we've got like about 15 minutes. Kelvin's going to give a deployment strategies talk, and so this is a really kind of jam-packed session with a lot of great content. So I'm going to let Kelvin go ahead and do that, and we're going to drop off, and we'll come back in a little bit.
Sure. My screens are already shared, right? Okay. So the first part, as Ron mentioned, will be focusing on the code deployment strategy. So this is more from AEM developers' lens, but it's not necessary to be only applicable for AEM developers, right? The strategy is applicable for all the developers who wants to learn App Builder. So for AEM has been evolved into cloud service. So is the deployment strategy, right? So AEM developers are getting used to the cloud manager, which is the Adobe's pipeline to help deploying or releasing the code into the cloud service. For App Builder, it's a totally different system from AEM. So there is some learning curve for developers, AEM developers to catch up or get used to some of the nuances. But the idea behind scene is pretty similar as how developers try to learn AEM stuff, right, from CLI to pipeline. So it's kind of similar strategy here. The first one that AEM developer comes to know Adobe App Builder is, of course, the AIO command lines. Once you have AIO app in it, you will get all your boilerplate code to be installed on your local machine. Then you can run just AIO app use. Actually, AIO app deploy. This will literally deploy your app into Adobe I/O serverless platform, right? So there are some nuances in this kind of deployment. Of course, when the developer is trying to deploy your the app into the cloud, you need to know what environments that you are deploying to. In App Builder, the term is called a workspace, right? As shown in the diagram, if we are building some integrations between AEM and an external party through App Builder, you can set up a different workspaces that can be mapped to your AEM environments. You can have development workspace mapped to AEM dev, workspace stage, or workspace production that maps to stage and production respectively. So when it comes to deployment, deploy your code, of course, you need to know which workspace you're deploying to, right? You don't really want to deploy code accidentally into production without testing it. So there are a couple of things AEM developers needs to be aware of is once you log in through AIO, it will land you onto one specific workspace, right? Usually development or stage. Then you can then there are a couple of files also will be available in your app build code base, which is .aio.env, which contains all the workspace information, as well as some of the credentials that is required for deploying the code. Of course, those files initially can be set up in developer's local drive. You run that AL app deploy, then you can deploy to the environment, of course, that is you first pointed to. Later, if you want to switch the environment, for example, if you want to switch from dev to stage, one thing you can do is to run ALO app use the workspace.json. That is a configuration file that you can download from the IO project, that is specific to each workspace. Then use that to swap environment. Then you can use AL app deploy to deploy to the environment that is you just switched to. So at least that can work on your local, but the thing is AIO file, .environment file carries the credentials that usually you really cannot check into code repo, right? Because those are the passwords that could involve some client secrets, password. You don't really want to expose through the code repo. So this relieves a little bit nuances that you have to keep some local copies of those environment variables, environment files into that is based on different environments. Once you switch to a specific environment using AIO app use, then you can use the local copy to revert those environment variables you kept for a specific environment, right? So that sometimes works most of the time for AEM developers or developers trying to get to learn AIO. That's the first thing you can do, use the AIO CLI command to do that. But when really it comes to enterprise level of code releasement as well as deployment, you really have to leverage a CI/CD pipeline. App Builder does provide the CI/CD pipeline support, especially from GitHub, leveraging GitHub's workflow. Behind the scene, this actually is leveraging GitHub Actions. In that case, you don't really developers don't really need to manage those AIO files or environment files that keep those secrets on your local machine. Then you can really leverage the GitHub secret vault or any pipeline tools that you can keep those secrets in the DevOps tools. Then you can run the CI/CD pipeline to deploy to the designated environment that you're trying to integrate with AEM. So in that case, you really can control the high-level environment with a pipeline permissions, so that developers can avoid deploying the code into a high environment by accident or whatever, right? So you really can have a high governance of how the code should be released or deployed to a stage or production environment. So with this, I think this can be probably suitable for anyone, a more kind of app builder customer tries to get onto a releasement. But what if you want to take that step a little bit further? Just think about a team that consists of two applications, right? One is AEM, the other one is app builder. You sometimes you really want to have a coordinated deployment, and of course you can deploy your AEM code in one cycle and app builder code in through a different cycle. But sometimes if they are those two processes out of sync, especially when it comes to a code dependency. Let's say if you are deploying your AEM code, which is a version 2.0, requires the version of app builder integration under a specific version that can make those two applications works. You probably need something that is more coordinated, orchestrated behind the scene to make this deployment process a little bit streamlined, right? So to solve this issue, this is more under the context of how you can make your code deployment more in a more of a high availability kind of mentality, right? So you don't really want to if AEM release manager is deploying the code without having the knowledge about app builder and app builder's team. Maybe it's one version behind. Then if you deploy the code ahead of that release, you make the production code broken, right? So this is really, we can leverage app builder's IO event to resolve this issue by itself. Literally, you can have the IO event listen the cloud manager's deployment pipeline event, especially around like you can listen the start end of the event of the pipeline run, or even in the middle of the step run, cloud manager step run. You can, based on your needs, you can trigger the app builder code deployment at the same time, right? So this really gives you the option to have orchestrated deployment experience rather than having more siloed deployment, which may cause code out of sync. So in the diagram, as a simple case, right, you could manage both code base into one GitHub common repo. And step 0 is some AEM developers is used to is it's always you can sync those AEM coding into Cloud Manager's repo. Then you can run the Cloud Manager pipeline to deploy the coding to AEM stage of production. Then the IO event can listen that Cloud Manager's event to trigger the app builder's code deployment through the common repo. So at least in the very simple scenario, you can make sure the same branch or the latest branch that of the code can be deployed to make to make the consistency across both AEM and app builder. Or if the app builder's code is outside of AEM's code repo, some of the mapping mechanism you can implement, and then the IO event can use that mapping to trigger the app builder's deployment against one specific tag or one specific branch if needed. So this really gives a little bit higher kind of introduction about how the code deployment strategy can be applicable to AEM developers, of course, to the broader team, as to anyone who wants to learn the app builder code deployment. In this coordinated deployment, you can think about AEM as a the app builder environment, or could be any external application, right? You want to integrate with. The IO event can even trigger non-app builders in deployment in that case as well. I do have a quick demo towards the end of this presentation. Yeah, if time allows, I can show the quick demo to you guys.
All right, that was good. So just to you had mentioned like if you one of the potential issues is that something could break if you're not in a coordinated deployment, right? And I think to be clear, anything that you do in app builders not going to break your AEM code, but it is going to potentially deliver unexpected,
Exactly.
outcomes, right? So that's really why you're doing the coordination, is so that there's what you expect to happen is actually what happens at the end, because you're on the same versions and there's no mismatch there, right?
Exactly. Because usually for AEM and App Builder, they probably will be two different teams, right? They probably can
Yeah.
manage coding to different code repos. So you don't really want to have one team is deployment without knowing the other team is doing, right? As long, especially in the case of those two code is dependent on each other, right? So you don't want
Yeah.
to have your code ahead of the other team when it comes to the code deployment releasement. Yeah,
Yeah, exactly. So this is super clever way of aligning those two development processes, so that you have a very smooth outcome, and something that's expected and repeatable, right?
exactly. Yeah,
Yeah. Okay, so I'm just going to pop this up. So if you've got questions, add it to the chat. I will put in a link for some of the deployment stuff around App Builder in the chat as well, for anyone that's curious. And then we will get to questions at the end. Scaling's kind of a big topic, so I wanted to make sure that we had enough time for the scaling topic. And as Kelvin mentioned, at the end, if we've got some extra time, we'll jump back into the coordinated AEM and App Builder code deployment demo that he's got for us. All right. I will jump out and I'll let you continue on the scaling side.
sure.
Okay.
So as most of AEM developers are getting used to the cloud service kind of mentality, when it comes to integration, more and more of the integrations are relying on non-JVM based extension, right? So, because from a cloud service point of view, especially from AEM side, you don't really want to have a long-running process running in the JVM that could potentially consume a lot of resources. Uh, um, this is more of the paradigm shift in terms of how AEM's extension should be handled. One of the major reasons to have that shift is to leverage App Builder as external serverless platform, which can literally give you, I won't say unlimited, but at least a much broader scale to support your heavy lifting tasks, right? So within AEM, the most commonly known feature that is asset compute service is already based on that model. So even for uh, client base or user based customizations, that is also shifting toward that kind of paradigm. So from the diagram here, on the left side, you have AEM, all sorts of API you can leverage to get things out of AEM. Also on the right side, you have third party that is required to be integrated, either Commerce Engine, the PIM, or even to AI microservices. To integrate that, App Builder in the middle really fits into that paradigm, because it not only provides a bunch of features from runtime to events, also give you the serverless platform that most of the developers don't need to worry about to stand up a new environment or something like that, right? So with that mindset, when a AEM developer or traditional Java developer comes into that kind of cloud-based development word, a lot of nuances are still kind of different from how traditional Java development works. Even the App Builder gives you the auto scaling part, but sometimes people will be are still seeing, hey, why my action is not is getting the 429 error, it's getting 500 of memory issue, those kind of things, right? So this is exactly the second part of this presentation what I'm going to talk about. especially on the scaling part. So before getting to the scaling techniques, I'm gonna use different patterns that we learned from our AEM field to talk through those techniques. But before getting to that, there's some of auto scaling concepts I want to introduce to the audience, so that can give at least some understanding of how auto scaling is working, or at least the idea state where you can leverage AppBuilder to give you most efficient way of to do things in the auto scale way, right? Because there's still some misunderstanding, misconcept in the field, saying, hey, AppBuilder or IO runtime gives you unlimited resources. You can just throw everything at it, and it can automatically or magically work out things for you. But things are a little bit different in that mentality. You still have to know some of the techniques behind the scene before you can get to that stage. So when talk about scaling, the most common use case is the batching process, right? So for batching, for any batch process, you can have like hundreds of, let's say, assets needs to be processed. For the simplicity, I only show like 10 assets in this diagram. One way of doing that in the traditional way, if you have a VM, you can process every single asset in a sequential way, right? So let's say if each asset takes about 2 seconds to process, you can process one after another. So total 10 assets will take like 20 seconds. Well, this definitely going to work, but it's not the most efficient way, right? Because you have to, the more assets, the more time you have to wait. So people say, hey, why not just start all those jobs at the same time simultaneously, right? So boom, you can have everything done in one shot. But the reality is the one virtual machine probably just can only have a limited resource. If you start everything at the same time, you're most likely going to blow up the VM, right? You're going to end up with some resource constraints issues. So the strategy for that is, in the traditional implementation, you're going to have parallel jobs. So within the same VM, you probably can start with a couple jobs, and each job can handle up to 3 assets. And between the jobs, you may have to wait a couple seconds for the VM to release some of the resources whenever one of the job is done, right? So this at least give you a way to boost the efficiency. Also not kind of reaching out to the capacity of the VM. So in this strategy, the total time would be reduced to 14 seconds. It's around like 30% reduction, which is not bad. But people say, hey, what if I have more VMs to support, right? I have two VMs. Then literally those 4 jobs can be executed at the same time, right? Without worry about reaching out the limitation of 1 VM. Yeah, sure, definitely, that's great. And in this situation, those 10 assets can be processed at the same time, and a total cost will be 6 seconds. It's like 70% of the reduction. It's perfect. That's how you usually do it in a Java or in the traditional way of the computing. But again, in the reality, getting additional VM or getting additional infrastructure setup means money and the time, right? This is really what AppBuilder can provide you. AppBuilder really can provide you those virtual machine in the terms in the AppBuilder's term or IO's term is as container, right? You don't really need to worry about the physical infrastructure, and IO runtime would auto provision for you whenever you reach to the point you need it, right? Also, your job becomes the activations. And this is what the beauty is, the serverless computing is, right? And if you can expand this whole batch into a more kind of scaling part, like it reached to hundreds, or if you want to handle hundreds of even thousands of assets in the batch, with the right strategy, the endpoint you should reach to that is something like this. So you can instruct AppBuilder or IO runtime to auto provision those containers to handle the amount of a batch or asset is coming from um, the list, right? And the more of the assets coming from the batch, the more container will be provisioned or auto scaled for you, and without having each container hit their limit, right? So most likely in this situation, of course, as the diagram states, this will be the ideal situation. Those assets will be balanced out or evenly distributed into the containers without reaching their limit. And the more assets coming out will be handled by the new containers that is provisioned for you. Um, uh, yeah, but if without having the right strategy, most likely people will get some of the throttling limitation from the I/O. That's something I really want to talk about in the next slide. So with that, I kind of so I want to have people bearing this in mind, and when we talk about more techniques about the throttling auto scaling strategy, we will come back to this diagram and to resonate why I'm using that one as an example. Now that's getting to the patterns in terms of how usually AEM or any third-party application needs to interact with App Builder using a few patterns that we already we kind of synthesized from the field, right? The first one is called direct sync or web action calls. In this pattern, App Builder or the IO runtime in the middle really acts as a proxy layer. AEM can, whenever AEM tries to integrate with a third party, they can make a request through App Builder. If you want to do any kind of API mashing or API transformation or data transformation, this is a common pattern you can leverage. Especially when we talk about the web action, it's more proper for handling those lightweight jobs. Just think about, for let's say a common use case in AEM, you want to have a workflow to triggered by user to get some external metadata synced back into AEM at the individual asset basis, right? So this is so to get the metadata from a third party could be one synchronous call from there that can be turned into the IO runtime or the web action can transform that data into the way that AEM understand and get back into AEM. There are a couple of parameters or throttling settings that are really relevant to this implementation. One is the timeout. So the web action comes with IO runtime, has a default timeout of 60 seconds. Of course, developers can tune this from to the lower end, but at maximum, your web action cannot exceed 66 seconds. Otherwise, you will get the 429 or the timeout response code. Really, for any synchronous call or web action call, if your call is making more than 60 seconds, that's really something you probably need to take a look how you can make your call more efficient, right? Also, there's another setting called the memory size. By default, the containers that IO provision for you to handle those kind of requests will be equipped with 256 meg only. Of course, developers can have the option to tune this up to 4 gig if it's needed, right? For lightweight kind of execution or activation, 256 up to 1 gig or 2 gig, I think that is sufficient for most of cases. But there are cases if you wanted to scale them up there to some heavy process, you have the option to tune that, right? So the first pattern is pretty common for handling those light kind of execution activations. But what if people say, hey, I do have some of heavy lifting job, right? So for example, the previous use case I gave was to synchronize AEM asset metadata through third party. What if I want really to leverage App Builder to export or import assets to a third party or from a third party? So the asset could be ranged from 1 meg to a few gigabytes. That exporting process can take more than a minute, right? So AppBuilder does give you another option to use. It's called the non-blocking action. So in this kind of pattern, whenever AEM is trying to request, trying to invoke a request to execute that action, the web action can take that request and response immediate to AEM is, hey, that request has been accepted, and this will be passed on. This request will be passed on to a non-blocking action to do the heavy lifting process. That process can have the maximum timeout up to 30 minutes. So in that case, you can have that job to run a little bit longer time. So to fit your needs, like exporting or downloading assets and pushing this to the third party within that time frame should be good enough as well. So yeah, this kind of pattern is pretty common. You can tell this is more of a synchronous way of handling the jobs rather than real-time handling. In the non-blocking action, you do have another memory size you can tune if you really want to tune this up to the level that you wanted to have more memory to handle your job. You have the option to that too, right? The next one is event-driven pattern. So the first two, they are more of driven by AEM. It's more, from the request coming from AEM. It's more of a synchronous way how those AppBuilder actions can be invoked. But when it comes to event-driven framework, AEM can be equipped with what do we call the AEM event package. So some of the AEM events can be subscribed, such as page or assets updates, creation, publication. Those kind of events can be subscribed to AppBuilder's IO events. Then the IO events webhook or action can handle this event and do the process as needed. So in this pattern, people mostly will encounter the scaling issue, because events can usually come in a big scale, especially when you handle those events such as a bulk updates, a bulk publishing from AEM. Usually can end up with like hundreds of assets, right? If some AEM author is publishing a folder that carries all the assets under that folder, like at hundreds or even thousands level. Those events can be triggered simultaneously and flooding to IO events. And eventually pass down to the IO runtime. If your throttling or your settings in your action is not set properly, most likely you will get either a timeout issue or the memory out of memory issue. So there's another one key parameter I'm going to introduce here is called concurrency. Concurrency, this is the meaning of concurrency is to define the maximum invocations that IO runtime gonna allocate into one container. So the default value is 200. That means the invocations or requests will be kept sending into the same container until this number is reached, right? So in other words, if you are having 150 or 200 events happen at the same time, and each event could take could have the action to take 5 meg or whatever kind of a resource in the memory to process. So 200 invocations will be kind of slammed into one action. And if you only have your memory setting up to a 2 gig level, so that means that container will not be able to handle that 200 request invocation at the same time. Most likely you will get out of memory issue or the throttling issue behind the scene. So that is really critical. Those parameters that you can tweak with. In that case, you can lower that concurrency, right? Let's say you can lower to 20, for example. That means one container can only handle up to 20 requests or 20 events. And based on the combination of your memory setting, that can give you a more sustainable execution throughout the whole event handling, right? So this really gives you the power um, to play around at the best combination of setting between timeout, memory size, and concurrency to get you the best results of handling the large scale of event processing. So just correlate this diagram with the previous diagram I showed over here. So you can imagine the batch could be the events that has been sent out into IO runtime, and based on the scaling technology that you can leverage. Here is setting up the concurrency. You really can have the control in terms of how many invocations can be allocated per container. Each container can have up to 4 gig memory based on whatever your requirement is. So those kind of combination of the settings can really give you a better picture to handle those events without having any issues that the resource can be hit the limit, that the resource limit can be hit, right? The fourth pattern I want to bring up here is event-driven journaling. Of course, the pattern number 3 is more about events that can be handled in the real time, because you can because those events will be sent over to the IO web action to handle simultaneously. But if your use case doesn't really require those events to be processed in real time, journaling is another pattern you probably can look into. This could give you another way of scale your process, plus the throttling parameters that can leverage here to give you a more sustainable execution or design of your app builder application, right? So the journal is nothing but a list of events. Whenever the events are sent over to IO events, they don't get executed right away, but they are written into the journal. And in your runtime, you can implement a scheduler to pull those events at your pace, right? So you can have the scheduler run every few minutes or an hour or daily to grab those events out of the journal and have a non-blocking action to execute or process those events. So this is really can by leveraging the journal and the non-blocking action, you really can expand this scale into even a bigger dimension, right? You can literally can process thousands or even millions of events based on your schedule. So try to correlate this one with the previous pattern. The batch itself, it is actually the event journal, right? So you not only would you be able to use the throttling parameter to control how many invocations can be allocated per container, you also can have the control programmatically to distribute your events using your own strategy as well, right? Yes, if you know your container can only handle like up to 10 assets, you probably can just programmatically to use a batch manager to distribute this into a sequence of the execution, right? And in that pattern, um, uh, this is really suitable. Like back to the use case I was mentioning, if you wanted to process or export hundreds of or even thousands of assets out of AEM, this is the the right approach, you probably can look into, right? Not necessarily you have to export, import those assets in real time, but if you have a kind of schedule-based exporting, this is definitely the right pattern you probably can look into. Concurrency, yeah, is the same as the one that I introduced before. So those are the 4 patterns that are well known from at least from AEM perspective. With all those throttling settings, it really can get you to a point to start your app builder applications implementation. But if you do have for all the patterns I mentioned above, of course, those settings are not necessarily just tied up to each pattern. Those settings can be applicable to any pattern, right? But if you come to the situation where the high demands of parallel requests are needed to be handled in real time, there are a couple of settings I put over here that probably you need to be super vigilant on. This one is the minute rate and the concurrent. The minute rate is IO settings that it's at the namespace level to isolate one tenant on the IO serverless platform from the other. So because the cloud is a shared environment, you don't really want to have one super highly congested loaded neighbor to impact others, right? So there are some default settings to ensure the sustainability of the IO runtime. So the minute rate is the first one that really limits you how many requests can come into App Builder or IO runtime at the minute level. So the default is 600 per minute. If you do have a big use case like handling thousands of requests at the same time, such as some of, for example, Commons integration, right? That's a common use case. You have a high traffic site, you may need to handle those requests through App Builder CF framework into the backend Commerce engine. 600 per minute might not be enough. It is not configurable by developer, but you can submit a request to the Adobe support to really bump it up that value to the one that you really need. Yeah.
Yeah.
Another one.
Sorry, sorry, Kelvin. I just want to jump in. And the reason we're showing like the default of 600 per minute and the range of 600 per minute, the range is it really depends. So it depends on a variety of things, and this is where contacting Adobe support is going to allow you to explain what you're doing, your use case, etc., and then allow the app builder team to really evaluate what that upper limit is, and they'll work with you on making sure. I just wanted to point out that it depends on the situation.
Right. Exactly. Yep. So I think it's a similar story as for the concurrent. Yeah. Don't get confused about this concurrent settings with the concurrency settings I introduced in the previous patterns. The previous concurrency parameter is action based, which means if you have an action, you can define those concurrency action level. But this concurrent is more at the namespace level. Namespace you can think about at the environment level, right? The workspace I introduced in the very beginning. This is how the microservices is segregated at the org level than your workspace level. Workspace is kind of similar as the concept of the namespace. So which means you really cannot have, by default, you cannot have more than 100 concurrent requests coming to the same namespace. But of course, contacting Adobe support can help you bump up that number to support the concurrent of the requests that are required. Yep.
That's great. Yeah, thank you so much. Because this was your last slide, right?
Yeah, it is.
I want to jump into okay. So can we go back a couple of slides? I had some questions. Okay, so yeah, so the event-driven webhook. I'll let you, take a drink or whatever while I while I chatter on. Um, so the concurrency, it's interesting the interrelatedness of these settings, right? So as you had mentioned, concurrency, if you're doing 200 and you're taking 5 megs of resource and you only do 256 meg, you're not going to be able to hit that. And so yeah, it's adding Jesse here since we're in conversation mode. So it's interesting that as you mentioned, there is a number of things that you can tweak and kind of figure out, play what if scenarios to really tune what you're able to what app builder is able to provide with this integration, right?
Exactly. So based on my experience with the customers, various customers, there's no golden set of the values of those parameters. Like say, hey, you set 256 meg, it's good enough, or you set to 4 gig is enough. It's totally based on the use case or the requirements you're dealing with, right? Also depends on what action that is specifically dealing with. So as I mentioned, the example, export AEM assets versus synchronizing AEM assets metadata. Those are two totally different level of handling, right?
Yeah.
Exporting assets requires more memory, more time to download big assets, or even ingesting to third party, or vice versa. For metadata, it's lightweight. You can have just one synchronized call to get that data coming to builders and transition back to AEM. So those are the different scenarios you need to think about. But the good thing is you do have those weapons in terms of the throttling settings to equip you or to enable you to the best situation, the combinations that can suit your needs. In the case of exporting assets, that each action may takes more resources for downloading an asset from AEM, right? So in that case, you can bump up your memory size a little bit higher to gig level, also reducing the concurrency to 10 or 20. That means like each container can only handle up to 10 or 20 jobs or invocation at the same time. This really give you more room to have those sustainability in the mind, right?
Yeah, and so I guess when you're doing this kind of, and you had mentioned when we were doing prep for the show that you had done, some analysis when you were working with a customer, and there's really a lot of kind of finesse that you can do to get to the right number, right? So what you
Exactly.
get out of the box is in terms of the numbers that you get by default are likely not the perfect ones because they're just, ballpark. And
Exactly.
by tweaking them, that's where you get the efficiency. It's going to cost you less in the long term to run these integrations, and they're going to perform better. You're not going to have those errors, right?
Exactly. Yeah. If I have another chance to come onto this show next time, we'll
Yeah.
definitely have a deep dive about that that client use case. So, in short, that use case is we were trying to export like 2,500 AEM assets out of AEM into a blob store outside of AEM. So by tweaking the throttling settings, we literally can do this like within like 1.5 minutes without crashing any of the containers. So yeah, so some of the learnings and the knowledge really can be shared. Yeah.
Yeah, that's excellent. Yeah, so thank you so much for that. It's a reason why we have the trial program, right? So App Builder trial is available. If there's anybody who doesn't have App Builder, you can get that trial. And the goal for that is that customers, partners, can try, basically, the question is, how many units of app builder do I need? Do I need 1 unit or 2 unit? Like how much capacity do I need? And the only way you're really going to know how much capacity you need is if you try the use case that you're trying to, leverage app builder for. You like build that integration as a proof of concept, plug in these settings and, work with them to figure out, how much capacity is really going to be needed? Because
Right.
it's not as simple like, well, I need 1 of these or 2 or whatever. It's
Exactly. Yeah.
yeah.
And another beauty of that is App Builder does provide you a very convenient way to tweak those parameters, right? Literally just one setting you put into the application YAML file, then you can just bump it up your memory, or even can get more containers as needed. This is I usually called App Builder scaling at your fingertips, right?
Yeah, there you go.
Yeah.
Yeah, and that was a plug, which I will throw into the comments right now for the blog post that you have on Medium about this topic. So definitely, folks want to take a look at that. A lot of great content. All right. So if there's any questions, by all means, throw them into chat. If not, yeah, I don't know. Do you want to?
The demo. Yeah, I want to show.
I want to see the demo.
We've got some time,
We
so
got some time, right?
we'll let you get on with the demo.
Sounds
We're
good.
gonna hang out, I think. Jesse, you want to hang out?
Yeah, absolutely.
Yeah. So,
Yeah, I mean, tuning is the right word for all of this, right? It's like, do you want a sports car or do you want a truck?
yeah.
And knowing which and tuning in that direction, and the things that you can configure yourself will cover a very wide range. So just knowing the trade-offs of each is important, but you can tune yourself quite a bit. So
Yep. There's no one size fits all, basically, right? So, and at least they give you the garage, all the tools in it, and then you can start playing around it, right?
Exactly. All right. Yeah. So, do you have to go to another screen or reshare or what? Or are you just ready to swipe over to? Oh, there we go. Beautiful.
So let's recap about what the coordinated AEM and app builder deployment is, right? So in the situation, you have one team of AEM developers who is developing all the AEM features. Also, you have another team, for example, app builder team. They are working on those features for the integrations, right? So those teams, AEM teams and app build team, they have to coordinate each other in terms of the versions. Let's say, let's give a simple example. Whenever my AEM release is coming to the latest version, the microservice on the app builder side needs to be bumped to the latest version. Otherwise, there would be a dependency mismatch, which may cause some unexpected behaviors. Of course, you can have some other strategies to make those version mismatch works using a version the package or something like that. But that's a little bit a different topic that we can probably cover later. But in a way of how to have coordinated deployment to ensure either the same branch of the code that manage both app builder and the AEM code can be deployed consistently, or have more kind of coordinated way to reduce the time of differences to boost the high availability of the code quality, right? So without having those kind of mismatch issue. So in this example, I do have this is my sandbox, right? So I have a dev, stage, and production. Imagine I'm doing a stage release for my latest of the code. for AEM. And I do have another code repo in my GitHub account, and that is for App Builder. So my AEM code is dependent on the App Builder code to make some integration with third parties. So this is the one thing that I built for OpenAI, but I probably can have another chance to to showcase this one. But anyway, so I defined a few workflows. By default, with App Builder's a template, it comes with a couple of workflows. One is called deploy to stage YAML, and the other one deploy to production. They are based on the branch merge. So whenever you merge code against the specific branch, it will deploy the code for you. What I did is I created a new one. It's called repository. That trigger is called a repository dispatch. This is more geared towards if you wanted to manually or remotely trigger this deployment from outside, right? You have to define a GitHub workflow based on this trigger. And another thing I want to show you is the environment variables and the secrets, how those things are managed in GitHub, not really through the local copy of AIO file or the event env file, right? So this is the secret vault that's provided by GitHub. So this is where you can define all those AIO credentials so that whenever you run that pipeline, run that workflow, those parameters can be picked up, those secrets will be picked up to enable the deployment happen successfully. So with those two things set up, whenever the idea situation is whenever I kick off my stage AEM deployment, this is going to kick off the App Builder's deployment as well. Right. Of course, as I mentioned, you don't necessarily need to just hook up with the Cloud Manager's pipeline start event. Based on your need, you can hook up with event of the pipeline end, or even in the middle of the pipeline run, for example, right before the integration test or the UI testing happens. If you really want to do some auto testing between two systems, right? So the Cloud Manager does provide those kind of events that you can listen to. So for the simplicity or demo purpose, I just hook up that event with the pipeline start event. So let me run this stage pipeline. So AEM pipeline started, and let's go to actions. Oh, here you go. You're already seeing this deploy to stage is happening right now. Yep, perfect. So those two siloed process are already be coordinated, right? So this is literally you can have one AEM release manager to control both code deployment in a more of orchestrated or coordinated way, right? Without having kind of a siloed process. So
Nice.
That's very cool. So it's listening, and so basically by just having the AEM team deploy, then it's going to redeploy whatever's in stage.
Right. Yeah. In such a case, you can have to coordinate, like only use the same branch of the code, make sure the code is inconsistent.
Yeah.
Or you can, if they are located in different repos, you can have some mapping mechanism to tell App Builder to deploy which version of the code, right? So behind the scene in the IO project, right? So this is where you define the Cloud Manager IO events. So I just kind of subscribe the Cloud Manager's pipeline execution started. And if you go to debug tracing, refresh the list. I think this is the latest one today that we just kicked off. And this is the event that is captured by the IO event. And based on the payload, which a program of the Cloud Manager is being executed, and use that to fetch a little bit more information from Cloud Manager, then trigger the right App Builder code deployment from your action. So I do have an action behind the scene to handle this event. to
Right
make
on.
everything
And
work.
you could have these actions or these events. You can create an app builder app that pushes into Slack or something, right? That then
Exactly.
notifies you on a different channel that these things have kicked off, and instead of coming in here, it would notify maybe a broader, like a development team.
Exactly. Yeah, you can do a lot of magical things from there.
Yeah, definitely magical. All right. So we are out of time. It is 10 o'clock right now, here, again, on the West Coast. We're all on the West Coast. So today for this show, I hope this has been useful. And yeah, thank you so much for joining us. The next session is going to be June 22nd. We're going to have a session on UI extensibility for AEM. And that one is going to be actually interesting that you've got OpenAI that you're showing this, because we'll have a little bit of AI in that one as well, and how you can extend AEM using App Builder and potentially using these AI services that are popping up to really extend kind of content velocity. There you go. So last thing I wanted to quickly mention, you may hear this, but for AEM customers, App Builder is now included. AEM as a cloud service sites, not if you're not on cloud service, and it's only for customers that own sites. So if you fall into that category, you can definitely contact your sales team, and they will get that 1 unit set up for you to use right away. And if you are a new customer, it comes with AEM as a cloud service sites. So that was all of the announcements. Thank you, Jesse and Kelvin, for joining me today, and have an awesome day, everyone.
Thank you.
Thank you.